In the previous video, we passed the collection through the program stop.mumps, which removed from each article, from each abstract, those words which are in the stop list, the unimportant words. The output was piped to stem.mumps, and stem.mumps reduced the words to stems. So if we had the word compute, computes, computer, computed, they'd all reduce to a single stem, compute. And the output of that, there's two outputs of that. One went to a file called initial stemmed docs.temp, and the other went to a file called stemwords.temp. This is, in the inset here, this is stems.mumps. And you see down here, if you recall, it opened a file called stemwords.temp at the beginning. We read a document in. There's our ZZ input. It reads the document into the array W, and I tells us how many words there were. We pull out, and we check to see if, of course, it's empty. We pull off the offset and the document number. Those are the first two things on a line on a document. We write those out to standard output to unit number 5, and then we processed each of the words from 2 through I, the decrement I because it goes from 0 to 99 if there are 100 documents. But anyway, we process each word through ZStem. ZStem takes the word and reduces it to a stem, and that would be X. We store the stem, and we store it in a global array called stem, the actual stem X, and the original word that triggered it. So we're going to have this tiny little set of trees where X will be the stem, and at the next level, descendant of it will be all the words that created that stem. So we'll have a translation dictionary from the original words to the actual stems. Then we write out the word X, the stemmed word X, to standard output, to unit number 5, followed by a blank. So what we're writing out is the original document. We're writing it out to initial stem docs.temp. When we get to the end of processing a document, this inner block here, we will write out a new line to unit number 5, which means we've written out the entire document. It's now one big giant long line, but all of the words have been stemmed. The other part of that is we write to unit number 1 the actual stem. So if the stem is compute, which is probably going to be in here several times because of computer is whatever, it'll be there multiple times in that output file. That output file will be all the instances of words reduced to stems. So anyway, that's so we get that as initial stems.temp. Now, as we move on further on here, we are going to, the next process here is it actually just lists the stems themselves. And let's bring up that program here if I can find the other terminal. Show stems.mumps. It simply goes through the global array stem for each W, for each stem. It writes out the stem W, and then at the second level it goes through and finds each S. So it will say for like compute, I would get computes, computer, computed, and so forth. And so it's a listing basically. So we get out of that. The next thing down here we're going to do is we're going to take the instances of all the possible words that was created in stems.mumps up above. These are all the instances. We're going to sort them alphabetically. So the input to sort is going to be that huge list of every instance of every word reduced to a stem. Okay, so it's just a big giant long list of all the words that occurred in all the documents that we processed, but they're all reduced to stems. We're going to run it through a sort, and since I didn't say anything, it's an alphabetic sort. You have to tell it if you want it to be a numeric sort. The output of that goes to unique, which, as you remember, unique counts the number of instances. So if we have compute in there 5 times, it will have one line in the output that'll say 5. Compute will say 5 and compute. It'll tell us how many times each one occurred, and that's the -C option with unique. The output of that goes to stemmed vocabulary.temp. It'll be a list of the unique words and the count of each one. Let's actually just try that at this point and see what happens. I'll just put an exit in here so it will stop. And index.script, and we'll say 1,000 just for sake of argument here. All right, we've run the program and we're back in index.script. The exit was initially put here. That was the wrong place. I moved it down here and reran it because it was put after the what was basically the output comment instead of the actual code. All right, let's look at what we got. The first thing we want to look at is stemlist.text. Stemlist.text looks like this. This is the hyphens there are due to code that had or words that had numbers preceding them. Let's ignore them. But we can see abate resulted is the result of abated and so forth. Abbreviation came from abbreviation. Some of these that didn't change are actually in here. So abdomen, abdomen, and so forth. Abdominal, abdominal. That the AL here is not a common English ending, and it would have been nice to somehow merge that into abdomen, but you need something more sophisticated in the lookup to do that. But you see down here abnormal, abnormal, abnormally, abnormality, abnormalities, abolish, abolish, abolished, and so forth. So it is so here's accept, acceptability, acceptably, accepted. The words are getting to some extent stemmed. There are better stemmers out there, and the better ones would be more desirable, but this works for our purposes. The concept is we are trying to stem. So this is the output of up arrow stem global array that has the stem, and then it has the original words beneath it. So, all right, the next one we wanted to look at here was up here was the output of stemmed vocabulary.temp. Well, we've got stemwords.temp. I should do that. Stemwords.temp. That's the entire, this one right here, the input. Let's look at that. It came from a previous step from stems.mumps. This is the entire vocabulary dumped out after having been stemmed. It's not by document or anything. It's just a continuous file. So if I do an ls on it, for example, or a word count on stem.words.temp, and you see it comes out to 71,707 lines. That's the total number of words reduced to stems that are in the first 1,000 documents after stop lists have been removed. Stop list words have been removed. Okay. Stem words.temp, and you can see it's just a long listing of words. Anyway, what we did up here is we processed them, we sorted them. These words were sorted, and you can see what a sort looks like. Oops. There they are. You just sorted them, and you got the Z's down at the end. So the word zone occurs quite a few times here. The word zymosin occurs 4 times. But anyway, so all the words, so the output of sort, this part here, going into unique, looks like this down here. All right. Unique then counts them and tells us how many times each word occurred, each stemmed word. And the output of that is stemmed vocabulary.temp. And you can see abdominal occurred 21 times, a bill, that could be the root of a number of things, 27 times. The roots don't necessarily have to make that much sense if you read them. They made sense to the computer. Acid 119 times, that sort of thing. We could actually find out, get that sorted too by simply saying sort-n and then pass as input stemmed, stemmed vocabulary.temp, and you can see it's coming out in numeric order. We could have put if we put an R in it, it would have come out in reversed order. But in the normal order, the highest count comes out last. And not surprisingly, the word patient is the most frequent word left in the collection. Remember, the stop list words are gone. So and or and of and the, they're not here anymore. Of the words that are remaining, having been reduced to stems, this is the most frequent word now, patient. And interesting enough, patient is not a good indexing term in a medical vocabulary. So we probably want to get rid of it. The next most frequent word is study. Well, an awful lot of these are academic papers. They're all studies. We've got 1,000 documents, and the word study occurred 471 times. Of course, it probably occurred more than once in some of the documents, but it's entirely possible that it occurred in quite a few documents. So are these really good indexing terms? The answer is probably no. So at this point in time now, we have got we've removed the stop lists, we've converted to lowercase, we got rid of the numbers and all of the trashy things that we really don't want to deal with, punctuation and so forth. We've reduced the documents to stems. The file containing the stemmed documents is initial stemmed docs.temp. And let's see. And it looks like that. Each document is again one giant long line. The first two items on the line are first the offset, secondly the document number. The contents are lowercase. Most punctuation has been removed. Frequent words, stop list words have been removed, and the words have been reduced to stems. So we are now more or less ready to start processing the documents.